All right, this is part 2 of 7.6. So we already talked about factoring completely. That would be following this chart, looking for the greatest common factor, seeing if there are 2 terms, 3 terms, or 4 terms, and then doing the appropriate factoring for each. So with 2 terms, difference of squares. With 3 terms, looking for our leading coefficient, if there's no leading coefficient or it has a leading coefficient, and then following through. And then for 4 terms, factoring by grouping. The second part we want to talk about today is solving by factoring. So we've learned how to break down numbers. So factoring is just like when we break down like a 6 or a 24 and we break it into its prime factors. That's what these are called. So 6 is just 2 times 3, but 24 breaks down in several different ways. But any way that you break 24 down, so I'll do this in red. If I used 2 and 12, I would break 12 down into 2 and 6, then 6 down into 2 and 2. 2 and 3. Any way that you break it down, you're still going to end up with the prime factors of 2 times 2 times 2 times 3. And I got that here too, even though I used 2 different sets of numbers. So factoring is just breaking down a polynomial into the sets of numbers that multiplied to make that polynomial in the first place. When we're talking about solving by factoring, it's going to give us quantities that multiplied together to make a given expression, right? That's what we already learned, what factoring does. But it helps us determine what the zeros are. And the zeros come in when we start graphing these. You're not going to see that yet. But we're going to start practicing it mathematically now so that we can apply it graphically later. Consider the equation 2x plus 5 equals 11. When we see an equation, we should know that in order to solve for the value, we undo the equation by doing the opposite. So think about 2x plus 5 equals 11. We would subtract 5 first, right? And 11 minus 5 should give us 6. And then we divide this 2 to find that x is equal to 3. That's the value of x. And if we were to plug that in, 2 times 3 makes 6, plus 5, 6 plus 5, does equal 11. So what this equation is saying is that 2 times a certain number, which we found out to be 3, plus 5 will equal 11. And with that information, we are able to undo the equation, which you saw me do here, in order to find the value of x. So in the same way, we can use factoring to help us find the value of x, particularly when our equation equals 0. So we want to find if our y value, so on a graph, if our y value is 0, that's on this this x-axis. Sorry, let me zoom in. What value for x on this axis here does y equal 0? And this is particularly going to come into play with parabolas. So there will be 2 places where x equals 0. Where y equals 0. It's a little bit to wrap our head around. I wish we were in class to actually talk about it, but hang with me here. Today we're just going to be learning the math behind it, and then we'll get to explore that a little bit further in Unit 8, I believe. So this is especially helpful when we want to know what the value of x would lead to an output or that's equal to 0. So we are going to follow the same exact process as factoring, and this is really important. So we're going to follow this same process that we've learned about in all of Unit 7 for factoring. But the main difference is that we are going to solve to find the value of x when the expression equals 0. And it's actually going to be an equation at that point when the equation equals 0. So here, look, all caps. I'm not yelling at you, but I want you to see this. We always have to make sure the equation equals 0 before factoring. So if we take a look at example A, we're always going to make sure this says equals 0. Right now it says equals negative 6x. So in order to get this to equal 0, we're going to have to add 6x to both sides. I'm left with x squared minus 2x equals 0. Now that I have that, my first step is to look for a greatest common factor. So in this problem, I have a common factor of x. And when I factor that out, I divide it from both of these. That's going to leave me with x minus 2. And then I'm going to look for my special pattern. Do I have a pattern of difference of two squares because it's two terms? And here the answer is no. So here's what we're going to do. We're going to take our outside value and set it equal to 0. We're also going to set our inside value equal to 0. And then we need to solve, because this is saying what value would x have to be in order to get everything to equal 0. And in this case, x would have to equal 2. Or x could equal 0. So I plug 0 in for x. 0 times 0 minus 2 would give me 0 times negative 2, which does equal 0. Or, if I used a 2, 2 times 2 minus 2, which equals 0, right? 2 times 0 equals 0. So the math behind it is pretty simple. It's complicated to kind of try and wrap your head around what's going on, but the math itself is really simple. Once you factor everything down, then you're just going to set each piece equal to 0 and solve. So let's try this one. X squared minus 66 equals negative 2. So the first thing I need to do is make sure this says equals 0. I'm going to do that by adding 2 to both sides. Now I can check for greatest common factor. There is not one. Then I'm going to see it has two terms, so I'm going to look for difference of squares. So there's no greatest common factor. Two terms, difference of squares. This is difference of squares. I can take the square root of x squared. Oops. I can take the square root of 64. I can make two sets of that. It's a special pattern. And it still equals 0. So now that I've factored that down, all I'm going to do is I'm going to take my first group, and that gets set equal to 0. Because if this first group is equal to 0, then everything else, so if x equaled negative 8, and I plug that in all the way across this, that would make a 0 here that distributes in or multiplies in, and it would 0 everything out. Okay, in blue, I could also have x minus 8 equals 0. So I add 8 to both sides. And x could equal positive 8. So these are our two answers. You're going to find a pattern here, especially with no leading coefficient, that it usually ends up being the opposite of whatever is in the parentheses. So we got negative 8 there. We got positive 8 there. All right. Let's make sure this thing equals 0 first. In order to get it to equal 0, I have to add 2 to both sides. That means 2x squared, minus, that's going to make 98 equals 0. Now that it equals 0, I'm going to look for a greatest common factor. I have a common factor of 2. So when I factor out a 2, that's going to leave me with x squared minus 49. Now I can look at, I have two terms. They're all perfect squares and subtracting, so this is a difference of squares. Take the square root of x squared, the square root of 49. Oh, I always do that. And then I get two sets, x plus 7, x minus 7. This 2, still chilling. And now we're going to work out each piece of this. So I have a 2 equals 0. I have x plus 7 equals 0. If I use a different color. And I have x minus 7 equals 0. Not red, green. So each piece, once we've broken it down, we're going to set each piece equal to 0. When we have a number, 2 equals 0, that's just not true. That doesn't work. So we don't have to worry about that one. Let's look at our next one. X plus 7 equals 0, we solve, and x equals negative 7. X minus 7 equals 0, we solve, and x equals positive 7. So these are the two solutions to this equation. We set equal to 0 and then we solve. We factor and then we solve. So, okay, just a couple more examples here. In order to get this to equal 0, I'm going to have to move both of these over here. In order to move them, I have to do the opposite to both sides. So check this out. These cancel out to make 0. 68 minus 5 should give me 63. Negative 11 and negative 5x will make negative 16x. And x squared is just chilling. So now, greatest common factor, I don't have one. 1, 2, or 3 terms, I have 3 terms. Means I'm going to use my big X. No leading, no number, no extra work. So 63 and 16. Negative 16. We'll multiply to create 63 and combine to make negative 16. And you can list these out. 2 doesn't work. 3 goes into 63 21 times. 4 doesn't work. 5 doesn't work. 6 doesn't work. 7 and 9. 8 doesn't work, and 9 we already listed. So those won't make negative 16. These can't make negative 16. These can combine together to make negative 16. They would have to be the same sign. Remember, no number in front, no extra work. So really, this expression is x minus 7 times x minus 9. And now we take each one of them, set them equal to 0. X equals 7. X equals 9. All right, I'm going to keep cruising here. In order to get this one to equal 0, I'm going to subtract 6x and subtract 3. There's no like term to stack here, so I'm just going to keep my 3 over the side. 3x squared. This would make negative 8x and minus 3. Now it all equals 0. No common greatest common factor. Big X, I have a leading number in front, so I'm going to do 3 times negative 3, negative 9, negative 8 goes here, and it looks like in order to multiply that, we're going to have a negative 9 times positive 1. I'm going to use bottoms up. My front number is my fraction, so I'm going to say that's over 3 over 3. With bottoms up, we have to reduce everything. So this has to reduce. It becomes negative 3 over 1. And 1 over 3 is already in its simplest form. It's already reduced. And I'm taking my bottom number, bringing it up. So that's going to be 1x minus 3. And I get 3x minus 1. That was from my second one here. Both of those are set equal to 0. So I got to solve x minus 3 equals 0. So x could equal 3. 3x minus 1 equals 0. And x can equal 1 over 3. So these are our two solutions here. I use bottoms up on that. You could use the box. You could use factoring by grouping, whatever you're comfortable with. Bottoms up is the fastest for me. All right, here we go. Example F needs to equal 0, so I'm going to subtract x and 1 from both sides. Gets those to cancel out to equal 0. Negative 3 minus 1 is negative 4. It's going to give me positive 7x and 2x squared. I'm looking, is there a greatest common factor? There is not. So I'm doing my first times my last. This is 3 terms, so I know I have to fill out my big X. Negative 8, positive 7. Looks like I should be using a positive 8 and a negative 1. These multiply to make that, combine to make this. There is a number in front, so there is extra work I need to do. Any strategy, I'm going to use bottoms up again because I find it to be the fastest and most effective. I reduce 8 over 2 to 4 over 1, and negative 1 over 2 is in its simplest form. So this becomes 1x plus 4 times 2x minus 1, still set equal to 0. So now we're going to take each of these and find what would x have to be in order for that to be true. What would x have to be in order for it all to multiply together and equal 0? In our first equation, x could be a negative 4, and that would just cancel everything out because 1, 0 multiplying with a bunch of things makes it all 0. In my second equation, x could equal 1/2. If I were to apply that, it would zero out my second group, which in effect would then multiply here to make 0 also, to clear it all out. So when we are solving by factoring, we are setting everything equal to 0 before doing our factoring. Once we've set everything equal to 0, we find our greatest common factor. We see if it's 2, 3, or 4 terms. We follow the steps depending on which. And the only difference then at the end is that we set every group equal to 0 and solve.